Here, I know some of you don't want this, but I had it already. I'm going to give you the practice final. Just so you have it. You can immediately put this thing away if you want to. I know the next test is still to come, so it's sort of like putting Christmas decorations up for Thanksgiving.
Christmas tree?
You're like, this is not quite a decoration.
There's a term for that actually, Christmas tree.
What is it? Christmas tree?
Christmas tree? It's a measure of how much earlier in the year Christmas is celebrated. Because every year.
There's a guy who's hanging that shit up.
Yeah. Well, can I grab one? Can I grab one?
Oh, right.
This actually doesn't look too terrible.
You don't know, you don't have to. You just add the points. So you don't have to have all. So do I just do? Well, because realize this too. Each one, so he adds
Put a pointer for y.
Yeah, so you can't. Exactly.
So they both only change by 1, right? So it's going to be.
All right, so who's got C2? C2 goes from 3, 1 to 2, 2.
I got something, I think it's wrong.
Okay.
It's y equals t plus 1
T plus 1,
and x equals t minus 1.
T minus 1. Oh, I see what you did. And what's your T go from to?
I think it was 2 to 3.
2 to 3, okay.
Yeah.
But then X would be 1 at 2, and X is not 1 in either of these. Do you see what I'm saying? So, there's a well-prescribed way of doing this. Personally, I always kind of rebel against that a little bit. You should be able to come up with, when you want to start at 3, 1, and go to 2, 2. So when t equals 0, you want X to be 3 and Y to be 1. When t equals 1, right there you should be realizing what's happening. When t equals 1, for example, I want X to be 2 and Y to be 2. So that means I want X to be 3 minus t, because after 1 I want it to go down to 2. And I want Y to be, now everybody else hold on, I'm actually going to show you how to convert this a little bit if you want to or not. It doesn't really matter. Yeah, Y, I want it to start at 1 when t is 0, and then go to 2 when t is 1. You guys semi with me? Or, you could figure out the equation of the line through there, and you end up with Y equals 4 minus X, and they'll let X equal t, and Y equal 4 minus t. What does it say? Doesn't it say X plus Y equals 4? What's X plus Y? 4? Yeah. I mean, do you guys start to see how these are connected, these ways of doing this? No? Okay. So, to be honest, I used this, but it doesn't really matter. So if I use this, did anybody else have something different between these two? Anybody else have a different way to do it? And you're all like, I ain't gonna tell you, man. Shit.
Like R equals 1 minus t times R.
Oh yeah, sure. And so if you do that way, what'd you end up with?
I think this one. I haven't figured it out.
Oh, okay. So yes, you could do it that way with R of t, but it's really the exact same math we just did just by looking at the things. Now, obviously, if I have a parabola, I probably want to do it more like this. Find the equation of it, and then let x be t, and see what y is based off of that. You can always do it that way. But now, what's dx? Negative dt. This is the step that people don't pay enough attention to. And you lose a negative, and everything goes to hell. And dy is dt, at least the way I've done it here. So now over there, I get, and what's t going from to? We've kind of forced it to be from 0 to 1. So it'll be integral 0 to 1. Square root of y. Oh, thank you. That was, so far it sounds like it's right. And then negative dt, is that cool? Dx is negative dt. Does everybody see that?
How do you get the t0 to 1?
That's what really got us going, right? At 0, it's 3, 1. At 1, it would be 2, 2.
Okay.
Yeah. So really, what t ranges from depends on how you set these up and how far you want it to go. All right, maybe. The process that you're talking about, the r of t equals 1 minus t, blah, 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 that always makes it from 0 to 1, which is kind of nice, but sometimes you want the flexibility to do more than just 0 to 1, to be honest. Plus, what's the square root of x? Square root of 3 minus t, and dy is dt.
Should we keep them separate or combine them?
Oh, I could have written them all in one go, but I put the negative out there, so I didn't. Then you just integrate those, right? The fact that they're square roots is not a big deal because they're just linear inside. Okay. So this will be, it's 1/2, so when you integrate it, it's going to become
Negative 1. No, 3 over 2.
3/2, so a 2/3 out front, 0, 1. Now here, now please, see this is where if you just don't use u sub when the inside thing is linear, just be smart about it, or use u sub, that'll work obviously. So this will be 3 minus t to the 3/2 for the same reasoning, 2/3 out here. But I would have a negative that would come out, so I better put a negative to kill that stupid thing. Do you guys see that? Or u sub and du would be negative and blah, blah, blah crap. Okay, and so just plug 0 and 1 in there and you get weird ass looking things, I think, right?
Isn't it supposed to be plus stuff there?
But when you integrate, you got to kill the negative that wants to come out of there.
Okay.
Yeah. So if you use u sub, it'll kind of happen for you. But part of me hates that. Part of me wants to be, I want to know what I'm doing. I want to know why that negative is there. I don't want to just, oh, it happens. But, u sub, nothing wrong with it. You can use it. No problems. And then you get whatever. When you plug 0 and 1 in there. You guys with me? I didn't, let's see, I think we should still get the same. Plug a 1 in there. 2 to the 3/2, which is 2 rad 2. So I get negative 4 rad 2 over 3, I think. Minus negative, so plus. When you plug a 0 in there, I just get 1 to any power is 1. So I get plus 2/3. I mean, now it's, please don't make me do all that. You can plug 1 and 0 in there, right? What about C3? So it's in a different region, so the values of y and x will be different along this region. Does that make sense? So we're integrating this function across these lines. So you can't just do that. Does it make sense? The function inside is not just 1, so I can't just look at symmetry in the picture and say, oh, good. So again, how am I going to set up the parametric equations for this? So it goes from 2, 2 to 1, 1.
It's just going to be basically reverse of what we just did here, right? It'd be x equals 0 plus t.
Yeah, you could say 2 minus t. And y would be 2 minus t from 0 to 1. There are definitely other ways.
Can't you just say x equals t, y equals t?
If you do that, it gets interesting because if you say x is t, y is t, then t's got to kind of go backwards, right? Which is not against the rules, but... And then you just do the exact same thing we just did. Do you guys see that? I mean, that's... So really what we're doing is sort of an expanded U sub. We're doing sort of like a T sub, right? That's really what this is a T sub. So everywhere I see dx, I better know what that is in terms of dt. Everywhere I see a y or x, I better know what that is in terms of t. dy, I better know what that is in terms of t. You guys see that? So it's really, anytime I suddenly change direction, I need to take that piece by itself and analyze it. Maybe. This is exactly the kind of problem you should be able to sink your teeth into. It's nothing, the actual calculations in this kind of problem are not intense. Shouldn't be. Sorry, I kind of gave up on it. I mean, here, dx will be negative dt if we do it this way.
And y will also.
If you do it this way, you got to do a little bit of weirdness. 1 to 0, t goes from 1 to 0, right? Which kind of accounts for these negatives here. That's why either way you do it, it should come out the same. All right, maybe that's enough of that problem. I think I got, did I ever get to the end here? Yes. I think after everything was done, I got this. All right. So you guys can check me out on that. You can see where the rad 3 is coming from here, right? When it says 0, you get rad 3 there. Weird stuff happens. All right, good. It's just a bunch of plug and chug. You should be like, oh yeah, give me a lot of that. I can plug shit in there and do stuff. And you should know me by now. I don't want to see decimals. I want to see radicals. Right? The exact answer, not approximate answer. Okay. We're the math people. The engineers can approximate. I know some of you guys are like, I'm going to be an engineer. You're not yet. So right now you're a math person. So exact answers for us, whoever the hell wants to use the results we get, the pure, beautiful results, they can screw it up and approximate. That's up to them. I like it. Of course, it is hard to cut a piece of wood at exactly rad 2 across. That is kind of hard to do. So I don't blame you.
Some would say impossible, actually.
Well, you could do it at camp shop and just accidentally do it.
Except it's irrational numbers, you can't.
Of course you can. All right. Where do we want to go from there? That was the one thing I left off of the answer kit. That's why we did number 10. Let me see. Was there something else? The things to notice from that quiz you guys took. I mean, obviously the average was really high. It wasn't meant to be really difficult. But one purpose for a quiz is to give you kind of a low stakes way of letting me show you what's important. So knowing what the hell phi is and what it is in relation to is important. And if you don't really know it, then you're going to make a mistake on the quiz in that respect. And then you're going to be like, oh, I'm not going to make that mistake again. I know what else. So if I say phi goes from pi over 2, let's say, pi over 2 to pi. What is that plucking out of r cubed?
Bottom part of the cube.
Sure. So everything below the
Or XY plane.
XY plane. I love it. So that's a quick way to say the region below the XY plane, right? Because phi starts here, so here it's going to be pi over 2. So from pi over 2 to pi, it's going to be everything below the XY plane because it's in relation to z. I love it. So how do you get over there? Well, theta gets you over there, right? So phi doesn't have to do that. Phi only goes like that, and then theta can take it wherever else it wants to be. Is that cool? So that was the two things. Two of the things that came out of the quiz was realizing that theta gives you the rotation you need. So in one respect, this should feel a little bit like the most hated thing from Calc 1 was the rotation of stuff like shells and all that shit. If you compare this to that, this is actually easier. But, well, maybe not. Depends on how much you understood it. But that's what theta does. It gives you that rotation. You can have this thing spelled out, and then theta gives you the rotation around so you get the whole bowl or whatever it is you're putting together.
Wait, in that case, when they eliminate everything above the X
How do you mean?
for if it's going from pi over 2 to pi.
Yes, it rules out everything above the xy plane. And then theta would say, if you want a complete bowl, you better go 0 to 2 pi. I like it. I like it.
Can we go over, like, even if we just do the example from that, just the order, like the order of integration, setting that up for finding of volume of an object?
So let me see, what problems did I give you here?
You give us the spherical coordinates cone and inside the sphere.
I don't think I gave enough, let's see. Yeah, I didn't. Well, I think it's just because this is from a semester when I put this after. But there is going to be 15.6 and 15.7 in addition to 15.8. So, right, this test starts at 15.6. I think back when I gave this practice test last, we'd already done it on the previous test. So 15.6, I'll tell you this. I'll give you this much to go on. Do not be as concerned about problems like number 36 in 15.6, where it said write the 5 other. I wanted to at least make you do that kind of thing a couple times in your life. What I'm going to do in the actual test, I'm going to give you the 3D object printed out on the test for you. Because that's the hard thing to do. You're going to have to do the traces. And this is where people are skipping. A lot of people, I didn't really get a lot of homework to look at, but the homework I've looked at, the mistakes people are making is they're just assuming what it does in the plane. You've got to draw the traces. So, I mean, in the XY plane, if it's going from this parabola to there, for example, you can't say x goes from 0 to 2 and y goes from 0 to 4. Is everybody cool with that? If I want this, no, right? So how can I set this up?
X goes from
Y goes from 0 to x squared.
Yeah, so you want to have the y inside, right? So that's one way to do it. As x goes from 0 to 2, y goes from
0.
X squared.
If I go from 0, see, don't forget to draw those arrows in. That saves you from that. I'm not picking on you, Dan, but because a lot of people do this. So I want to go from here to there. So from x squared wall to 4. So that kind of mistake is easy to make. Especially if you don't draw it out for yourself. My God. So I will give you the 3D generated thing, because that's the hard thing to kind of generate on your own. But you should, if you don't, I don't understand you, you should draw out the traces in all the planes. It helps you pick what your input plane is going to be, and hopefully you guys understand what I mean when I say that. So here, if there's another DZ, there's my input plane. I'm treating XY as my input plane. And then I can say Z goes from, so if Z's hovering over this, Z goes from 0 to whatever, right? Or if Z is some paraboloid doing something like that, maybe, then Z goes from negative rad whatever to positive rad whatever over this region, right? Maybe. So picking your input region, and then also, there's a problem in the homework, I can't remember which one. It was the intersection of two paraboloids, maybe? Shit, I don't remember, I can't remember. There was one thing, and then intersected with some other thing. And here's the XZ plane, I think. Here's the, what? So it's not that tells you the region in the input plane. It's, in this case, it would be the intersection of these. You got to get the broadest thing. So this point has an output. So this intersection, you have to find the intersection between these two. Does this sound familiar to anybody, this problem? Find the intersection of those two, and then put it down in there. And then draw that by itself. Then you can figure out, as X does this, what does Z do? Right? I mean, these are the kind of things you have to do for yourself. So I will be nice. I will give you the thing that's really difficult to do. Obviously, here's an example of how hard it is to graph in 3D, right? You guys have good imagination, so you can give me that. It's not just some exploding pill or something that's up here. So I'll give you that, but you got to do your traces. I can't believe it's already basically December. It's crazy, man. Every year goes faster.
It doesn't.
Carpe diem. Huh?
It doesn't go at the same speed every year.
No, it doesn't. I remember when I was 6, summer lasted forever. Right? Right? And then school comes, you're like, what? I go, where? Oh, yeah, I remember this shit. Maybe I didn't say it like that when I was 6.
Yeah, and speeding up the earth.
What's that?
Yeah, it must be it.
Speeding up the earth's melting around the sun.
Oh, I see. All right, so it's happening for everybody, not just me. Okay. The last 16 years have been like, I still remember like, 3, 2, are we all going to be alive after this? Oh shit. When 2000 rolled around. We made it. And then 2012 was the next thing. Oh my God, with the Mayans, what were they talking about? Nothing. Okay. Sorry. I have no idea what got me under that.
Could you get
Is there anything we haven't talked about that's still troubling? I mean, I recommend you do odd problems in sections that give you the most trouble. In fact, if this is a section that you have no trouble with, don't even finish the homework. I can't believe I'm saying, oh my God. And go back and focus on the sections that give you the most trouble, obviously. I'm still going to be like, finish this shit. What the hell? You, like I keep saying, you take control of your own education. You focus on what gives you the most trouble. Yeah.
There's a difference between the moment of inertia equation and if the moment of inertia, but if the density is constant.
All right, let me just say this. We could talk about that all day. I'm not going to put any density, moment of inertia stuff on this test. You understand? Again, it's a prescribed way of doing things that uses the processes that we talk about. If you go further in physics, you will definitely be doing that kind of thing. But if you don't, then you won't be. So what I'm most concerned about here is, do you understand the process itself? And it's always nice to see how other disciplines use pure math. But, I'm a little biased towards pure math. But, I'll give you some applications with that.
So you won't put math instead of math either?
Say again?
Math instead of math?
No, I won't put that on there either. So I figure if you've done that homework, you've already experienced that. If you're going further in physics, you should definitely pay attention to that. Some of you guys maybe have already experienced that somewhere else. I don't know. Yes, you're like, that's enough. I don't need 1.5 classes worth of this. Thank you. All right. Anything else? All right. I'm okay with an early day.
Yeah, so much.
It's fine with me. When it's rough for you this time of year, it's the same thing for the teachers.
Take some more pictures for the 53.
Oh, do you just want to borrow the book again?
That would be great.
Yeah, just follow me to the office.
Awesome.
Sure.
Are you going to be available via email this weekend?
Always. Why? What's going on?
I'm